Welcome. In this video, we're going to take a look at problem 66 out of Chapter 6 of University Physics Volume 2 by OpenStax. The problem states that at the surface of any conductor in electrostatic equilibrium, the electric field equals sigma over epsilon zero. We need to show that this equation is consistent with the fact that the electric field equals K times Q divided by R squared at the surface of a spherical conductor. Okay, so we have E equals sigma over epsilon zero. And we also know that sigma equals charge per surface area. The surface area of a sphere is 4 pi r squared. So we have sigma equals Q divided by 4 pi r squared. So let's substitute for sigma. We have Q over 4 pi r squared. And that is going to be times 1 over epsilon 0. Let's rearrange. So we're going to have Q over 4 pi epsilon 0 r squared. Now note that the Coulomb constant K is 1 over 4 pi epsilon 0. So we can rewrite our expression as K times Q over R squared. And this is what we wanted to show. I hope you found this video to be helpful and that you enjoyed it. I will see you in the next one.